So then the second AS question, just what have I labelled it? So June 19, Unit 2, Question 1. 3 events A, B and C are such that the probability of B is a fifth, probability of C occurring is a sixth, probability of A or B 3/4, probability A or C is 5/6. The events A and B are independent, so I don't have to worry here about proving it. They're telling me that that's the case. Find the probability of A. So A and B are independent. So therefore, probability of A and B would be the probability of A multiplied by the probability of B. I don't know anything about the intersection, but I do know what the probability of B is. So the probability of A and B occurring is going to be probability of A times the probability of B, which is a fifth. So the probability of A and B occurring is a fifth of the probability of A. Now we also know, using the general addition rule, that the probability of A union B, which I haven't used yet but I have been given, is A or B less the intersection. So let's put in everything I know here. I know that A union B is 3/4. A is what I'm trying to find. I don't know B. Sorry, I do know B. It's a fifth. I don't know, I'm not given A intersection B, but I do know from here that it's a fifth of PA. So now I've got an equation where the only thing I don't know is the probability of A. Lost my calculator. So I've got 3/4 less a fifth. Which is 11/20 equals PA less a fifth of PA, which is going to be 4/5 of PA. So to get PA on its own, I'm going to divide 11/20 by 4/5, which is 0.8. So PA is 11/16. So that's part A. Part B. Determine whether or not A and C are independent. So this time they're not telling us that, so we've got to look for consistency between the two different approaches. If I bring this down so that I know the probability of A is 11/16. I know the probability of C is a sixth. So I'm saying if it's independent, I know that the probability of A and C occurring is 11/16 times 1/6. Let me just move to a different calculator which has got the fraction button working on it. So 11/16 times 1/6 is 11/96. So that is from that relationship. And I also know that the general rule is also A union C is A or C minus A and C. I'm given A union C. I know that A is now 11/16. C we're given as a 1/6. Which gives me that. So A intersection C, rearranging that, will be 11/16 plus 1/6 less 5/6. If that works out to be 11/96, they're independent. So 11/16 plus 1/6 minus 5/6 is 1 out of 48. They're not the same. Inconsistent. Therefore A and C aren't independent. And finally, part C. What can be said about the events B and C if B intersection C is an empty set? So that's its definition for mutually exclusive events. If one occurs, the other can't. There's no overlap. So you can say they're mutually exclusive. Okay, so there's 6 marks overall for that question, and the way the marks were allocated in the actual exam paper is, for the first one, there's a method mark for correctly applying the general addition rule. There's 1 mark for correctly substituting everything in, and there's 1 mark for getting 11/16 out of it. For the second, there's a mark, a B mark, a standalone mark for figuring out the 1 out of 48 using the general addition rule. There's 1 mark for getting the 11/96 from the multiplication rule, and there's an explanation mark for showing that they're different, so they aren't independent. And there's a final explanation mark for correctly saying they are mutually exclusive. So we've got 7 marks there. 1, 2, 3, 4, 5, 6, 7.